Okay, we're ready to start talking about how to do functional programming using Scheme. And there's a few things that I have to say to get us started. So first of all, if you want to do this, you need to download a particular program. I'm going to show you that program right now. So go to the interwebs, type in Racket, and if you go to racket-lang.org, you'll see this really cool website with lots of documentation and all kinds of cool things, but you want to go to the download directory and it'll figure out what platform it should download for and then download that file and install it. So whether you're on Windows or Linux, let's say, oh yeah, you're all set. You can do Linux, Windows, whatever you want. And once you've downloaded it, then when you run it, you're going to end up with something that looks like this. Basically, you have two screens to operate in. The first screen is where the first panel of the screen is, well, I said two screens, but really I have two panels. So the first, or let's say window, the first window is where you're going to define the functions that you're going to use to operate on in the language. And the second one is where you're going to execute the functions. Now, the way Scheme works is that you define functions and then run your program. You run your program right here. All right. Now, I'm going to try, rather than writing with a tablet, I'm going to try typing here. To do a comment in Scheme, you say, sorry, you do semicolon. So Scheme history. So there's a couple things that you probably want to know about Scheme. So it was a variant, or sorry, it became a dialect of Lisp in the 1970s. It has very simple syntax and simple semantics. You're going to love it. It's very easy to learn the language. It's actually quite popular, or was for a while, in CS1. There's some colleges that still teach this as their primary first language because the syntax is so simple and the semantics are so straightforward. It's a great way to learn how to program. But for those of you who have experienced programming using recursion, you know that thinking recursively can be a little complicated. So can you imagine if that was your first programming language? Maybe you would have liked it, maybe you wouldn't. I don't know. So Racket is a dialect of Scheme. So most of the things that you can do in Scheme, you can do in Racket, but Scheme itself is somewhat limited. So we went from Lisp, which was incredibly robust and rich, but a little bit overly complicated because it had lots of features, to Scheme, a big contraction and simplification, to Racket, which was again adding new features, but sort of modernizing Scheme so that you, for example, build a web application or a graphics application using a Scheme dialect. All right, so let's talk about some characteristics of the language. Well, one thing is it has static scoping. So that's really interesting. All right, so you're not going to find, you're not going to be able to, you're not going to have things that are accessible within a method. They'll be accessible in the method, but not outside the method. And there's no dynamic scoping. So as a method calls another method, you're not the things that are accessible in method A, which is called by method B, isn't dependent on the order that things were called. All right. So functions can be defined in a number of ways. So they can be the result of an expression, which would be interesting. We'll see that. They can be a list element. They can be a parameter. And they can be created on the fly. So you can actually build a function as part of the execution of your program. That's really wild. So you actually have code building itself. So I'll give you an example of that later. So a program is simply a collection of functions. Functions. And the way this entire environment works is through this thing called the interpreter. And the way the interpreter works is we read in an expression, evaluate the expression, and we output a result of evaluating the expression, repeat. That's pretty much how your program works. So typically what's going to happen if you want to run your program is you're going to go down here to the second window and type in some function name. And that function will do some processing and call another function, which will do some processing, which will call another function, and so on and so forth. Okay. So let's look at some simple expression evaluations. All right. So in order for you to follow along with what I'm doing, what I want you to do is I want you to take a look at this bottom left-hand corner, and you have the option to set a language. I think it's set to pretty big right now by default when you start it, but I've set it to advanced student. So I just want to make sure that you've done that. Once you've set the language, you need to click run for the language setting to take effect. So you just click run, all right? For me, it doesn't do anything, but for you, the screen will probably flash. Okay, so let's do some real simple expression evaluations, all right? So I'm down here at the interpreter, and I'm gonna say, hey, evaluate the expression 1. And shockingly, it says, well, if I evaluate the expression 1, that returns the value of 1. Now I'm gonna say, evaluate the expression of 5 times 2. Now, here's something to be aware of. In Scheme and Racket, expressions are evaluated using prefix notation. So that means that the operator comes first, followed by the operands. So star 5, 2. All right, that's going to multiply 5 times 2. So this is going to take a little bit of time for you to get used to, but believe me, with a little bit of practice, it'll become second nature. All right, let's add 5 plus 2, and well, so here's what I'd like to do. I want to multiply the expression 5 plus 2 and 5 minus 2. I want to multiply those two expressions together, all right? So remember, I want to multiply the expression 5 plus 2 times the expression 5 minus 2, and I want to multiply those two things together, all right? So to do that, we've got plus 5, 2. That's one expression. Minus 5, 2. That's the other expression. But I want to multiply those two together. So I'm going to put the multiply here. And now I have my result. So you can see how the prefix notation gets a little funky, right? But my goal is to multiply two expressions. Here's the first one. And here's the second one. Let's make these a little bigger so they're readable. Okay, so if I do that, boom, it says it's 21. That makes sense. 5 plus 2 is 7. 5 minus 2 is 3. 7 times 3 is 21. Fantastic. All right. So let's talk about some primitive functions. All right. So primitive functions are, let me go here, new topic, primitive functions. Primitive functions are, another way to say it is they're the sort of basic operators that are available in Scheme. So these would be multiply, divide, add, subtract, and there's a whole bunch of other ones, but I'll just give you an example of another one, and that is square root. So those are the primitive functions. Now each one of these takes arguments, one or more operands, depending on what you're doing. So here's an example. We'll do an example down at the bottom here. So star 3, 7. So the first argument here is the primitive function. It's actually, I'm gonna say that these are primitive numeric functions because there are functions that do other things, which we'll look at in a little bit. So the multiply is the primitive numeric function. The parameter, we've got 3 and another parameter, 7. Okay. Now, here's another one. Oops, I'll just click one here. Okay, let's do another one, square root. So square root 4. So square root is the primitive numeric function, 4 is the parameter, and we get a result. Now here's another one, star 3 plus 4, 5. Now in this example, this is the primitive numeric function, this is the first parameter, and this entire expression is a second parameter. And so the second expression is an example of functional composition. So we're passing in a function, the function which is the primitive numeric function plus 4 or 5 as an argument to this multiplication primitive numeric function. And that'll get evaluated as 27. Okay, so that takes care of primitive numeric functions. And I guess I'll put it as a comment here, an example. We'll just have it preserved, square root 4 as an example. Okay. All right, we also have something called numeric predicate functions. These are functions that basically, what we would call, they support Boolean expressions. So we're going to say supports Boolean. Including numeric. The Boolean expressions that include numbers. Okay, and let's list those operators. So that's going to be equals, not equals, greater than or equal to, less than or equal to, even, odd, 0. Okay. And let's do an example. All right, so we'll do an example of we'll do a couple examples. So let's say equals 5, 5. So is 5 equal to 5? True. So this error that's appearing at the bottom is occurring because I'm adding comments to the definitions window. And it doesn't really need to be rerun because the comments don't affect anything, but I'm just getting a warning about that, just so you know. Okay, so let's see. So 5 is equal to 5. True is 5 equal to 0. False is even 6. True, 6 is even 3. It is not even. Is 0 minus 5 star 1, 5. Does that expression evaluate to 0? Well, yeah, it does, because it's 5 minus 5, and that evaluates to 0, so that should say true. Okay, cool. So you get an idea of what these numeric predicate functions are, and they're basically giving you support for Boolean expressions. All right. Now, of course, how would you use those Boolean expressions? We'll take a look at that in a second. But now we're actually ready to define some simple functions. All right, so we're going to define a simple function. So you want to define the simple function up in the upper window, the definitions window. And then once you've defined it, you need to go over here and click run. And that will basically have the interpreter examine the function, make sure there aren't any syntax errors or anything like that in the definition. And it'll make the interpreter in the bottom window aware of your function definition. So I'm just going to define a simple function area. So I'm going to say define area R. Now, you notice I just hit enter. The reason why I did that is there's a formatting that that you typically do to make your functions more readable. So let's talk about what I did up here to start. So define is a keyword that says I'm about to define a function. Then you do an open paren and you put the name of the function. So area is the name of my function. Then you follow it with a list of parameters. So this function only takes one parameter, R, that's in the list. All right, now I'm going to define area as star and I don't know why I did that. It should just be pi r squared. Oh, I see. Yeah, it's just pi r squared, right? Let's make sure. I just had a brain fart. Area of circle. So if you guys were here, you would just tell me this. Let's see. Area of circle. Math is fun. Look at this. Okay. Yeah, that's what I thought. And my notes say something different, which is why I got a little concerned. Okay. So it's pi times r squared. And notice as I do this, close the parens, we've got a really nice, I might even put that paren here. All right. So that's pi r squared. All right. Now I've defined the area function. If I hit run, I now have area compiled and the interpreter is now aware of it, so I can invoke it. So I'm going to say area and 3. All right, so the answer for the area 3 is this number, 28.274, etc. Okay, so a couple rules about defining functions. You can use alpha numeric, but start with alpha. I just switched to lowercase. Yeah, it's okay. It's case sensitive. And the parameters in semantics. So you can't change the value of the parameters. The parameters are read-only. Okay, cool. All right, so the next thing I want to show you is how to do control flow. So the goal here is we'd like to behave like a mathematical function, all right? So if I were to say factorial of n, and I'd like to do 3 equals, but I can't type it, but factorial of n is defined as 1 if n is equal to 0, n times f of n minus 1 if n is greater than 0, and undefined if n is less than 0. Okay. So some things to note here: only one predicate guard will be true for any n. And when predicate guard is true, returns value of expression. Okay. So the predicate guard is a fancy way of saying this piece right here, that's the predicate guard. Oh, sorry. That's the predicate guard. And here, this is the predicate guard. So the thing to the right of the if is the predicate guard. Okay. So let's do an example of defining the factorial function. So we're going to say define factorial n, and then we're going to say if equals n0. So that's our Boolean expression. We're going to do 1. Sorry, we're going to do 1. And the else statement appears immediately after that. So star n times factorial of n minus 1, so minus n1. Whoops. And then we're going to close that if. And then we're going to close the define. Okay. So there's our predicate guard. It's kind of like your standard if statement, but the way the if statement works is the first line after the if statement is going to be executed if this is satisfied, and then the second line is going to be executed if the if is not satisfied. Now, I didn't add anything for being undefined, we can talk about that a little bit later, but for right now, I don't want to worry about it. Okay, I'm going to run this. And of course, You know, I have a little bit of experience with schemes, so I'm not getting any syntax errors. But if I did have a syntax error, it would let me know. And now I can try factorial. So let's see. The factorial 5 would be 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120. So the answer should be 120. So if I say factorial of 5, I get 120. Awesome. So this is an example of control flow, and the specific type of control flow here is selection, and this is two-way selection using if. All right. I hope that as you program using Scheme, you actually do not use the two-way selection using if. Even though the if is super familiar, there's something that's much better that is sort of a combination of a switch statement and an if, else if statement. All right, and that is n-way selection using something called cond. All right, so the n-way selection using cond, I'm going to give you the syntax. Actually, I'll give you the example. Let me see how you return undefined in all right, so it looks like I can return the constant undefined here. Okay, cool. So the reason why I'm doing this is I want to get us set up for a nice example using cond. So cond is n-way selection. So that's like an if, else if, else if, else if. And here's how you set up cond. We're going to do define factorial 2 takes in n. And we're going to create a cond semi. So you say cond, that means here's the condition. And then you're going to follow this by a list of predicate guards. So the predicate guard, the first predicate guard is equal n0. So if n is equal to 0, for factorial, we want to return 1. So you just do that. All right, so there's the predicate guard. Oops. There's my predicate guard. If that's satisfied, that's my return value. All right, we can do a second predicate guard. Greater than, n is greater than 0. What are we going to return? We're going to return times n factorial minus n1. Okay, and then our final example is going to be if, well, there's two ways to do this. So one way to do it is we could say greater than n, less than n0. So if n is less than 0, then we're going to return undefined. All right. Let me just compile this and make sure I got that undefined defined correctly. Doesn't like that. Let's check the syntax I have over here. Boy, that looks pretty good. Well, let's try void instead of undefined. See if that works. It also could be the version of the language that we're using. So let me change that to void. Oh, it does not like that. Make sure I got that set up. Oh, you just say void. Oh, maybe I just say undefined then. All right, let's try that. I could edit this out and make it look like I knew exactly what I was doing, but really, let's try that. Okay, it's cool with that. Let's try undefined. I prefer undefined. Oh, it doesn't like that. Okay. How about pound undefined? Nah, it doesn't really like that. Okay, so we'll just return void. Something bad happened if we return void. Okay. All right, cool. So now if I do factorial 2 and I pass in 5, I get 120. And if I do factorial 2 and I pass in -5, I get void. So this is a really sweet, clean way of writing code that involves n-way selection. So the n-way selection could be 2, so it's just like an if-else, and it could also be if-else-if, or it could also be, it's not really, it's sort of like a switch case, but not exactly, because we've got Boolean expression after Boolean expression. But what I like about this is it creates really nice, tightly formatted and clean looking code in Scheme. So I highly advise you using cond and blowing off the if statement. It is possible to replace this last predicate guard with else. So that's a catch-all that says if we didn't hit this first predicate guard and we didn't hit this one, neither of these are true, then do this one. This is sort of like a default. Or the else at the bottom of an if, else, if chain of statements for n-way selection and other programming languages. All right.